See this? Can you all see the presentation okay?
Yep.
Okay, well, good evening all. I know many of you in the club. For those that don't know me, I'm Steve, K1rf. I'm a retired digital design engineer, ran a group of PC board and FPGA designers. I've been an engineering manager, program manager, and had no time for ham radio, but now I do. And how did I come about putting this together? Well, I know several of you in the Stamford club have had very good luck with off-center fed dipoles, and it made me curious. I wanted to learn more about them. I'm a big fan of low-cost multi-band wire antennas, so I wanted to learn about this one more in depth. So I joined this groups.io, OCFD, and there's a lot of really talented people in there. And I ended up joining a group within that group with some of the technical experts there. Okay, let's see. I'm not sure why. Okay, there it is. In search of the Holy Grail. Everybody wants a multi-band simple wire antenna that's low cost, easy to build, doesn't need a wide range antenna tuner, and easy to deploy. And the off-center fed dipole is a pretty good attempt at finding the Holy Grail. The Windom antenna itself has a long and storied history. I have a link in here that lists all the people involved, but it started around 1929 or so. There was a guy who wrote a thesis paper on an off-center fed antenna, and he was trying to basically prevent standing waves on the feed line. But Windom got the credit when he published a QST article in September 29, 1929. Since then, over the next 30 years or so, the single wire feeder was replaced with ladder line. Ladder line was replaced with coax and an ugly Balun by a guy named Buck Rogers, who actually had an antenna company, Buckscom. Later on, it was replaced with a coax plus transformer in Balun. Then the Carolina Windom came into play. That actually uses a piece of coax as a radiating element. And since then, much testing and advances in both tools and building antennas and trying them resulted in different feed point splits, better balance, and even an end-connected off-center fed dipole, which I'll talk about. Most of these modern designs are not really Windoms, although the name kind of stuck, kind of a brand like G5RV. A guy named Serge Struenband, ON4AA, published a little article in one of my references where he showed what does SWR look like for each band as a function of frequency. And it looks like a whole garbled mess over here. However, if you look at certain points, you'll notice that a lot of the low SWR points for all the bands sort of merge around certain points. So it appears that certain feed points might be promising on what to use for an off-center fed dipole that supports multiple bands at relatively low SWRs. So that's been studied to death. One person actually made a big spreadsheet of all this stuff. So it's really been studied in great detail. There's a guy who I've become pretty friendly with named Rick Westerman, DJ0IP. And he probably spent 10 years of his life working with off-center fed dipoles. And he basically came up with some recommended feed points and what bands are good. If you want certain walk bands to work, certain splits are better than others, etc. So he recommended some possible ones to use. But here's what he says. Use either a 20% feed point or one of the two 29% feed points. He personally built about 20 of the ones that use the 29.7% feed point, hung them in many different locations, all styles from flat tops to inverted V's, etc. And they always work on those 5 classic bands. So my recommendation is the 29.7% feed, because that also supports 15 meters. Now, I'm going to talk about recommended configurations that you could build yourself. You could also buy these, but you could build them as well. Here's one for 80, 40, 20, 15, and 10 with the 29.7% feed point that Rick Westerman talked about. It's 134.9 feet long. Now, it turns out that at that length, the resonant frequency on 80 meters is actually outside of the 80 meter band. It's at around 3.44 megahertz. But due to an end effect, you need that low frequency to start off, and then all the higher frequency points will resonate. So what do you do about 80 meters? It's too low. Well, what you could do is you put a capacitor in there at roughly the middle of the whole length of the antenna, and you can use that to raise the resonant point on 80 meters, and you could actually move it around. You could set it to the low end or the high end or wherever you want, and it has almost no effect on the higher bands. Now, this next slide, I'm showing you a comparison between VSWR for a 29.7% split, which covers 15 meters, and the classic 33.3% split. The 33.3% split is a fine split. It's been used for many years. It's proven. It's easy to remember because it's a 2-to-1 split, and it has low VSWR on the bands it's designed for. However, it's not designed to cover 15 meters. The one with the 29.7% split has a nice low VSWR on 15 meters. The one with the 33.3% split, a lot of people will try to use it anyway on 15. They use their nice wide capability antenna tuners. But here's the problem with that. The actual VSWR of that antenna on 15 meters is something like 17-to-1. Let's round it off to 16-to-1. So what happens is the voltage on the coax is about 4 times normal. By the time it goes through the Balun at the antenna, which multiplies it by another 2 times, the voltage on the Balun, which drives the antenna, is now 8 times larger than what it is on the coax. So you're stressing the Balun very badly with voltage. There's a risk of having arcing inside the Balun when you try to run on 15 when you shouldn't with that one. The other problem with it is you have a big loss. You have on the order of 8 dB of loss. Now 6 dB is a factor of 4 power loss, which means at best, if you're using a 100-watt rig, you're only going to get about 25 watts into the antenna. So it's very inefficient and bad for the Balun. So when the manufacturer says don't operate on 15, you shouldn't. Okay, let's see. Next slide. Now here's the 40-meter version that's recommended. It's about 68 feet long, and it has a 40.5% feed point split. And that works well on 40, 20, 15, and 10. And I just simulated what the VSWRs would look like there with the hybrid Balun and with 50 feet of RG8X. And they're well within the 3-to-1 VSWR capability of most rigs, except for 10 meters. 10 meters at the high end, excuse me, goes up to about 3.5, but most tuners will easily match that. So it has good VSWR performance. Now let's just talk about balance a little bit. And I want to spend quite a bit of time talking about them because the Balun is the heart of the off-center fed dipole. The Balun typically is 4-to-1 or 6-to-1 from different vendors, but my own simulations show that 4-to-1 usually gives lower VSWRs and is simpler to construct for good performance. 6-to-1s are rarely required. And Rick Westerman, who did a lot of work with Baluns independently, told me that 6-to-1s rarely are needed in his experience. Now, here's the problem with OCFDs, which has to be addressed, and it could be addressed properly. Because the antenna is not symmetrical, the outside of the coax picks up RF, and that needs to be addressed because the common mode that develops on the outside of the coax actually becomes part of the antenna, skews many of the antenna's characteristics, including resonance. Worse yet, the resonance point varies with changes in length of the coax. So you really want to minimize common mode current on the outside of the coax. And the larger the feed point offset, the larger the common mode problem increases. So if you have a choice of antenna splits, you want it closer to the center. As you move towards the end, the common mode current becomes higher and higher, and it becomes more difficult to tame it. And end-fed antennas, end-fed half-wave antennas, is sort of an extreme version of an off-center fed dipole, and it has the worst common mode, which has to be addressed. Let's see. Now I'm going to talk about some of the balance. The 4-to-1 Ruthroff is a voltage Balun. You could think of it as an ordinary transformer with a center tap secondary, where the center tap is tied to ground. So it makes equal voltages at the output, but it doesn't control the currents. These are typically made with parallel or twisted pairs with about 100 ohm impedance. And they typically use type 61 ferrite, which is very efficient ferrite. They're very good for impedance matching, for a 4-to-1 impedance match. They have very wide bandwidth. They're not good by themselves because they don't have very much common mode choking at all. And the reason for that is, if you look at the diagram on the bottom, one side of the one output is going directly to the rig. There's nothing in between. Excuse me. So there's no choking at all on that one side. On the other side, currents are flowing in opposite directions in the transformer, so they tend to effectively reduce the common mode choking capability. And it varies as a function of what the current differences are in the two ends. It's fine for a Carolina Windom. A Carolina Windom uses a section of coax as the radiating element. So it works okay for that, but not for off-center fed dipoles by themselves. The next type of Balun is a 4-to-1 Guanella current Balun that does give current balance, which is what you want. It does give choking, and it's made from 2 toroids typically, and these are wound with either twisted pairs or parallel lines, again with 100 ohm impedance, and the interconnection of them gives you a 2-to-1 voltage ratio or 4-to-1 impedance ratio. So that does both the choking and the impedance ratio, and it's not bad. They work good for 40 meters and above. They're more difficult to get good choking on 80 meters. You could use another technique, which I'll talk about. But first, let's talk about the 1-to-1 Guanella. This is typically wound with 50 ohm coax. It has very good choking. In fact, it has twice the amount of choking as the choking in a 4-to-1 Guanella that's made with the same toroid and the same winding. So this gives very superior choking with twice the choking impedance of the 4-to-1 Guanella. But you can't use it by itself because it only has a 1-to-1 impedance ratio. To make a 6-to-1 Balun, you could make it out of two 4-to-1 voltage Baluns. You connect them properly, you interconnect the inputs and outputs properly, and you get a 6.25 impedance ratio. So the main disadvantage of this is it needs an additional toroid to get the 6-to-1 instead of 4-to-1. So this is what you want to use, a 4-to-1 hybrid Balun, which is a 1-to-4 Ruthroff voltage Balun going to the antenna, and a 1-to-1 Guanella Balun for choking. And that gives the minimum amount of complexity for impedance matching as well as good choking. So that's the recommended Balun. Here's a picture of one made by N4CY, who also was one of the experts in the OCFD group, and he built a lot of Baluns. In fact, I bought a Balun kit from him, some toroids and some very narrow but high power coax. So this is what you want to use. You could build it yourself or you could buy commercial ones. This was a little bit closer picture of the hybrid Balun, and I won't go into any detail there, but you can kind of get a flavor for what that is. He used a stack for the voltage Balun with parallel wires, and he used a single toroid with coax for the 1-to-1 Guanella Balun, and that used type 43 material for the Guanella and type 61 for the 4-to-1 Ruthroff. This next slide shows what Everett Sharp, N4CY, called the mother of all Baluns. This can handle up to 1,500 watts. And the interesting thing I wanted to point out here is, number one, it's not all that complicated, and it runs cool as a cucumber. But the secret here is the Guanella is doing all the choking. Choking is what causes the power dissipation. All the power dissipation is in the Guanella. So he used two cascaded Guanellas, which is not used very often, but it's a really good technique, because what happens is, since they're cascaded, you get twice the impedance, twice the choking impedance, or half the current, and you have two toroids. So whatever power is left is being shared between two toroids. So each toroid sees a 4-to-1 power reduction by cascading two of them. So that's a real powerful technique. And again, this is not that difficult to make for handling 1,500 watts. It's actually pretty nice. And one other comment on Baluns. It's not a bad idea to build it yourself if you're a builder and you want to undertake that project, but you know you'll have a good Balun. A lot of vendors make false promises or just plain scammers. You'll reduce your costs a little bit. You'll be proud of what you built. And very, very few vendors really know how to make a good hybrid Balun with good choking. Balun Designs has a hybrid Balun, and it has inadequate choking on 80 meters. So if you make your own and you copy one that other people have developed, it will work better, most likely. Now, I just want to show you, if you wanted to kind of build your own antenna and spend a lot of money for really premium components, if you wanted a high power or center fed dipole, you could buy a good hybrid Balun from Palomar Engineers. It's like 139 bucks. If you need one that's relatively low power for 100-watt rigs, they also have like a bullet type hybrid Balun, which is 109.95. That's a lot lighter weight, so you don't have this big heavy thing hanging down from the middle of the antenna, or you need an extra support for it. And you could buy some expensive wire from DX Engineering, and you could buy some expensive end insulators. I like these. I bought like 8 of them. The nice thing about these insulators is there's no clamps involved. It's like these little steel things that you have on your garage door wires to terminate the wires. You just sort of feed them in and out of these loops at the end. But you could adjust the antennas very easily without constantly screwing and unscrewing clamps. So I like those a lot. But even with all this, it's like $182 or so for a high power one, or about $150 for a low power one. That's all super premium components. Recommended antennas, if you want to just buy a ready-made one, I would recommend the Aerial 51 as my first choice. It's sold by Spider Beam. The US rep for that is Vibroplex. They have a 600-watt version for $249, or a low power version for $129. It covers 8 bands plus 30 meters at lower power. And it was designed by Rick Westerman. And I put some links for reviews in there. He used he called it a current sum technique for figuring out the feed point. He just took all the bands and looked at where's the current the maximum if you add up all the currents and all the bands. And it turns out that that feed point is not very different at all from the recommended feed point. Very, very, very close to it. Palomar Engineers also sells an off-center fed dipole. High power to low power, it goes from $239 to $169. And those are good. They have good balance. So once again, the balance is really important to get good choking, and either of those would have a good balance with good choking. Okay, now we go off into a couple of different topics. I claim you can mount the hybrid Balun at ground level. Nobody ever does that. I think some people did it in the early development stages when they were using ladder line. But instead of putting the heavy Balun up on top, you could put the heavy Balun at the bottom. Use some 300 ohm ladder line, such as the one made by DX Engineering, and make this about 50 feet long for a 40 meter antenna, or 100 feet long for an 80 meter antenna. Put the hybrid Balun near the ground and feed it with 50 ohm coax. So that solves the problem of the heavy Balun up on top, and you will get low SWRs with that. I talked to Rick Westerman about it, and he didn't trust it. He says, until you actually build it and test it, you can't claim anything. But I'm confident in the simulations I did, and that should work. Although I haven't tested it. Okay, now we go into Neverland over here. Unusual off-center fed dipoles. One that I think in the United States, no one ever heard of at all, is something called an end-connected off-center fed dipole, or EC, OCFD. This came into being around 2010, or maybe a little earlier than that. An antenna was developed called the City Windom, which was developed by UA3 AHM. And then more work was done in it by Robert Brown and Dave Cutter, as well as Mel Farrer. Some of those folks are in the groups.io off-center fed dipole group. The basic idea of this is kind of similar to sleeve dipoles. Some of you know there's some VHF type antennas which have a quarter wave section which sits outside of the coax and a quarter wave radiating element on top. It's really a half wave dipole. But Phil Salas, AD5X, developed what he called an end-fed, center-fed 20-meter portable antenna in QST magazine, May 2022. It basically used the coax itself with a choke at the bottom of it, a quarter wave long, and that became a radiating element, half of the half-wave dipole, and then he had wire for the other half of the dipole. So this end-connected off-center fed dipole, the same idea, except you making an off-center fed dipole rather than just a simple vertical dipole end fed. And here's a picture of it. Essentially, you have coax going into a choke balun. Then there's a section of coax, 50 ohm coax, which corresponds to the short leg of an off-center fed dipole. And then you have a 4-to-1 Ruthroff voltage balun at the other end. But this is not connected in the usual way. Normally, a Ruthroff balun has two outputs to drive the two halves of the antenna. This one is more like an auto transformer. It has a transmission line transformer, and you feed the center into the middle of this, and then this other section multiplies the voltage up. Sometimes you need a capacitor, sometimes you don't. For the 80-meter version, you more often than not need a capacitor there to make everything line up. And these could be used just like an end-fed half-wave, flat top, inverted L, inverted V, etc. And you might ask yourself, well, what's so good about this compared to an end-fed half-wave? Well, the main advantage I see is that the transformers are much more efficient. They're much more wideband and they're much lower loss because they're transmission line transformers and low turns ratio transformers. An end-fed half-wave transformer is a conventional transformer, very inefficient. The best of them may have half a dB loss. These together have probably 0.1 to 0.2 dB loss, so they're much lower loss. And just for the heck of it, I simulated one in an inverted L configuration, mounted about 30 feet above ground level. And it worked pretty good. I got low VSWRs with it on 40, 20, 15, and 10, well below 3-to-1 SWR. So the thing actually works. It's great if you're like in a building, excuse me, and you have to stick an antenna out your window. Well, if there's a tree outside, you could feed one end from your window and feed the other end off a tree, or hold the other end off a tree. Okay, now we're getting into a real Never Never land. One day, Rick Westerman brought up to the group, he saw something in one of the forums. It was a concept from W8JI, who has a big website with a ton of stuff on it. And it was a hand-scrawled sketch of a very compact off-center fed dipole. The idea of it is you have a 4-to-1 hybrid balun. You have a relatively short wire from it, 27 feet long, which represents the short end of a 80-meter off-center fed. And it's pretty low to the ground. This one was 8 feet above ground level. And then the long wire of the off-center fed goes up and it's an L. So the whole antenna is only 92.5 feet long. So if you have a very compact backyard, this might allow you to get on all bands 80 through 10 that you couldn't do with a normal, 135 foot long off-center fed dipole. Well, I scratched my head on this and I said, could that really work? And I played with it a bit in SimSmith, later version of SimNeck and EasyNeck, and using those two together, plotted some SWR curves. And lo and behold, the thing actually works. The only limitation is that on 80 meters, the bandwidth is a little bit narrow. So you have to adjust the capacitor in there to put the resonant point on 80 meters where you want it. If you're a CW guy, you put it down lower. If you're a phone guy, you put it up higher. But it does work. It's very efficient, and it gives you a compact antenna. So then, just for the heck of it, I actually did this morning. I said, gee, what if we try to apply that to a 40 meter off-center fed dipole? So I just made up something. And this one has some really good uses. It's only 34 feet long. Its maximum length is 34 feet long. It's almost half the length of a normal 66-foot, 40-meter dipole. So I just set this arbitrarily to 7 feet above ground level. You need a 12-foot long short section. And then the sum of these two is the long section. And you feed it with a hybrid Balun. And I like the 7 feet because you could kind of reach it with a step stool, but it keeps the radiating element out of harm's way, so you don't get a shock from it, and you don't get tangled up in it. So physically, it's kind of nice if you have two supports at 30 feet, and the SWR performance looks quite good. Again, it's way below 3-to-1 SWR, except for 10 meters. On 10 meters, at the very end, it went up to like 3.2. This was simulated with a hybrid Balun and with 50 feet of RG213. If you use RG8X, it would probably stay within a 3-to-1. So it has amazingly good VSWR performance. It's very short. This one needs no capacitors, inductors, or traps or anything. It's just wire in a hybrid Balun. So if anybody wants to build that, let me know, and I'll be happy to try to help you with it. But I'm confident it'll work, and it's a great compact antenna. It has good radiation patterns. 40, it's kind of omnidirectional. 20, it's broadside to the antenna. 15 and 10, it's kind of more omnidirectional, but the elevation patterns are good. So it has good antenna patterns, easy to make, as long as you have the supports available, and very compact. And then I just have some resources at the end. Again, for those that want to learn more about off-center fed dipoles, join the off-center fed dipole group at groups.io/OCFD. And if anybody would like a copy of this presentation, email me at k1rf@arrl.net, and I'll be happy to send you a copy. So there you have it. And just one last thing, if I could get it up on the screen. Let's see if I can. Can you all see this?
You still see your PowerPoint?
Still see the PowerPoint?
Yes, sir.
Okay. Never mind then. I wanted to show you what the simulation looks like, but that's not that important. It's just very easy with the simulation to put in different Baluns and actually simulate them accurately, put in different feed lines with their losses, simulate them accurately, and look what the composite SWR will look like as a system. So I use EasyNet and SimNet a lot to do that. So there you have it, folks. Are there any questions? Guess not. So that's the story, and I turn it back to Steve.
But I was just wondering, would this make a handy setup for field day?
Absolutely. It'll make a great setup for field day.
Yeah. I've gotten away from antennas, but you've sparked my interest to get back into looking into them more.
Yeah, Rick Westerman, who lives in Germany, has a very small garden, a back lot. they don't have the luxury over there that we do over here sometimes. So he's been trying to come up to get a compact antenna that'll work on 80 through 10. He's looked at different options. So this one was something he wants to try. And he also may use the N connected offset in the fed dipole in an L configuration. He hasn't decided yet. So he's going to build one of those and see what happens. But I'm confident that the 40-meter one will work well and it's very compact. And if you're at a field day site that doesn't have much room, that could be a good option.
Yeah, I find it rather fascinating.
Yeah, I mean, I just came across this in the offset the fed dipole group within the group, some of the technical experts. We have our own little group within the group. So it's quite interesting. I thought it was interesting.
Yeah, you got it. I'm getting, as soon as I can, I'm going to start playing around with the antennas again. Rather inspiring.
Yeah, you could really do a lot with just wire and a Balun.
Yeah, so the expensive part, I guess, is just getting the good Balun for it.
Yeah. Yep. Well, build your own.
Yeah,
Join the OCFD group, and there's plenty of files in there on how to make your own Balun if you wanted to do that.
yeah, it's been a while since I've I in a situation where I don't get into the ham shack very much late nowadays, but I really want to get back active again.
Well, that's great. I haven't done enough antenna experimenting myself, and I'd like to do some more myself.
Yeah.
Any other questions?
Yeah, I have a question. I noticed that most of these antennas were not optimal on 30 meters, and well, I'm using my antenna is a Tar Heel screwdriver, with a 30-inch whip on my balcony, and yet for some reason I do my best FT8 around the world. Well, not totally around because it stops at places, but I've done very well on the 30-meter band with my FT8. And I'm just wondering, I mean, I see the 40-meter bands busy and the 30-meter in the evening gets busy. So would I assume that the people that I'm getting are not using wire antennas, but they all have these pictures of these monster beams in their backyard, and it's like a David and Goliath thing. I put out a peanut signal, but if they've got low noise and are putting out high power to me, we can make a QSO. So if they got the power, I got the noise, you see.
Right. Well, the big antenna helps both directions. So you hear
Right.
them a lot more easily, but they also hear you a lot more easily.
Yeah,
So they're helping you that way.
that's good that there's plenty of those around.
Yeah, this is not particularly a good antenna for 30 meters. If you used a 20% feed point split, it would work. You'll get a 4-to-1 SWR, which is not too bad.
Yeah,
But
that last antenna you showed with that you were designing yourself looked like an interesting design.
Yeah, unfortunately, that one doesn't cover 30 meters. It's good
Well,
for-
it could probably be made to, right?
yeah.
Yeah, you just change the parameters.
Well, you could shorten it and make it work on 30 meters. In fact, it might work on your balcony on 30 meters.
Yeah.
It would work quite well. You just couldn't use it on other bands. That's the only problem.
Well, yeah.
Or maybe some of the walk bands might work. I didn't really experiment with that.
It's interesting. It's really, your talk was very interesting, and it certainly covered a lot of material that I don't think everyone's or anyone is familiar with.
Yeah,
Sure.
it's very hard to come by it all in one place. And I try to do that here based on what I learned from the OCFD group. And if anyone has more interest, just join that group. And there's lots of data there, files and how to make balance and so forth.
Thank you.
Okay, so I'm going to stop the share at this point and give the floor back to Steve.
All right, thank you, Steve. I appreciate your work and all the effort you put into that.
My pleasure.
Anybody else got any other questions for Steve that, you might wanna? No?
Hmm.
All right, well, like I said, thank you, Steve.
You're quite welcome.
Anybody who wants to